Hi guys, today we're going to be graphing a system of linear inequalities. This is a type of problem that gives a lot of students a tough time, but they're not actually that hard. You just have to get used to doing them and go through the steps. So here's an example we're going to do. A linear inequality looks like this. It looks like a system of linear equations, except the equal signs are replaced with inequalities, and if we want to express the solution to this system, we have to graph it. There's no other way to express it algebraically, so we will be graphing this. Our first step is to graph the associated lines. We just replace the inequalities with equal signs for now, and we're going to graph the lines 3x minus 4y equals 12 and 3x plus 2y equals 6. We have to graph these as dotted lines because the original inequalities were strict. They were this one was less than, this one was greater than. If they were less than or equal to or greater than or equal to, the lines would be solid. But in this case, since they are less than and greater than, the lines themselves are not going to be part of the solution. So the way that we denote that is to use dotted lines. I'm going to go ahead and graph these two using the intercepts method. That just means I'm going to find the x and the y intercepts for each of these two lines. If you feel more comfortable finding the slope and intercept form of the two equations, y equals mx plus b form, you can do that, but I feel that if the equations are in this form, it's easier just to find the two intercepts. So I'm going to call the first line my red line. I'm going to plug in x equals 0. It's going to give me minus 4y equals 12, divide both sides by negative 4, so y equals negative 3. Our y-intercept of the first line is 0, negative 3. Same thing to find the x-intercept. I replace y with 0. We get 3x equals 12, and dividing both sides by 3, we get x equals 4. So I'm going to go ahead and plot these 2 points and draw my red line that goes through them dotted. So here is my y-intercept, 0, negative 3. Here is my x-intercept at 4, 0, and here is my line that goes through the two. I graphed it in red and dotted so that I can keep it separate from my second line. Alright, I'm going to go back and do my computations to find my intercepts of my second line. Okay, same idea. We're just going to find the intercepts of my second line, which is my blue line. Plug in 0 for x, that will give me my y-intercept, which is 0, 3. Plug in 0 for y, that will give me my x-intercept, which is 2, 0. I'm going to go ahead and plot these 2 points and the line that goes through them. I'm going to plot that as a blue dotted line. Okay, here is my y-intercept of my second line and my x-intercept, and here is the line that goes through those. So I've got my red line and my blue line drawn now. Now I just have to figure out which side of these lines I have to shade, and I do that by plugging in my test point, which I'm going to choose 0, 0 because it's the easiest to do and it's clearly not on either one of those lines. So I'm going to plug in 0 for x and 0 for y into both of the original inequalities, and that will give me information on which side of the line I should shade. So if you plug in 0, 0 and you get a false statement out of your inequality, that tells you that 0, 0 is not part of the solution, and the half plane containing 0, 0 would not be shaded. If in fact you get a 0, 0 plugged into your inequality gives you a true statement, then the point 0, 0 would be part of your solution and you would shade that side of the line. So we're going to do that separately for each of the blue and the red lines. I'll be right back. So I'm going to plug in 0, 0 into my red line, which is my first line, and you can see when you plug in zeros, everything just kind of melts away and you're just left with something very easy to determine. We've got 0 is less than 12, so be careful at this point. Really think about this. I see a lot of students do the correct computations and then they don't pay attention here, so they end up with the wrong true or false outcome here, but 0 is in fact less than 12, so that's true. And for our first line, 0, 0 is a solution to the inequality, so every point on that side of the line containing 0, 0 will also be a solution. So let's go ahead and graph that. Okay, so for our red line, we're kind of ignoring our blue line right now, but for our red line, 0, 0 is a solution, so we want to shade above the red line. That's the half plane pertaining to the red line that contains the point 0, 0. So I'll go ahead and do that. There we go. Now I want to ignore the red line and the red shaded area and do the same thing for the blue line. So I will go ahead and plug in 0, 0 for my blue line and figure out which side of that line I want to shade. Okay, so for the blue line, I plug in 0, 0, I get 0 is greater than 6, and that is false because 0 is not greater than 6. So for the blue line, I want to shade the other side that does not contain 0, 0, because the half plane that does not contain 0, 0 will therefore be the side that contains the solutions. Okay, so for my blue line, the point 0, 0 is not a solution, therefore our shaded side should be up and to the right of the blue line. So I'll go ahead and do that. There we go. And the solution of our system of inequalities is going to be the overlap or the intersection of the two shaded areas. So from this picture, the solution to the system of inequalities is this purple area. So it is not the blue area here, it is not this red area, it's only this one section of the graph here. And you can still see that the lines are dotted, so the points on these lines themselves are not solutions, but every point that's included in this purple area will be solutions to both inequalities, and those are the points that we want. Okay, that's all for today.